This is week 3, homework solutions. And the first 4 problems are graphical solutions to two-dimensional situations. Now, obviously, in a medium like this, I can't really show you how to graphically do things, but I'll try to give you an idea of what you would need to do in order to solve these problems graphically. Well, first of all, you need a protractor and a ruler that you can use to measure angles and distances. And so when you do these 4 problems, 2, 4, 5, and 11, you need to do them with those implements in hand. The first of these is number 2. And number 2 states that to find the following path in figure 354, the total distance traveled and the magnitude and direction of the displacement from start to finish. Now, what you do when you do this graphically is, first of all, you set a scale and you say something like 1 centimeter is equal to 120 meters. Then you lay your ruler down and you first put a point at your starting point and you travel 1 centimeter because that's the distance that you need to travel. And then the second, you draw the second one and then you connect those with a connecting line, which you're going to measure. You measure that connecting line, and you find that that connecting line is approximately 3 centimeters in length, and so the distance is approximately 360 meters. Then you measure the angle here, either this angle right here or this angle right here, either one, and that defines the direction. And if you do that, you find the angle is 70 degrees north of east. Now 70 degrees means what the angle you found was this angle down here. And it's 70 degrees this way using the protractor to measure it. Number 4 is very similar. Number 4, again, you start out by stating that 1 centimeter is equal to 5 miles, and then you draw the different lines that are related to that, the proper length, and then the last line is this connecting line, which you're going to measure. When you measure that line, you find that it's 6.2 centimeters in length times 5. Then using your scale, you find that it's 31.0. Then you measure this angle with your protractor, and you find that that's 50 degrees north of west. So it's 31.0 miles, 50 degrees north of west. Number 5 is, again, very similarly done. You start out with a scale. 1 centimeter is equal to 4 meters. You draw your first line, and you end up drawing a triangle that looks something like this. And you're going to measure this length right here. When you measure that length, you find that it is 4.55 centimeters, and then using your scale, it ends up being 18.2 meters. And then when you measure this angle, you find that that's 7 degrees, 7.3 degrees south of west. Again, all of these are just using a protractor and a ruler to carefully draw what you're supposed to be drawing, and you're measuring angles based on that. The last one, you basically start out with a line. You draw your X and Y axis. Using your protractor, you measure an angle that's consistent with the angle that it requests and draw the line. And now you have, this is Vy now, and this is Vx. And then you use, again, you drew this line based on a scale that you set. In my case, I set 2 meters per second is equal to 1 centimeter. And so when you do that, when you measure this line, the x line, Vx, is going to equal 2, which is your scale, times 2.07. So your Vx component, your x component of that velocity is 4.14 meters per second. And the y component is going to be 2 times 2.6 centimeters approximately, or 5.20 meters per second. Now obviously these kind of graphical calculations, the accuracy of these kind of graphical calculations are based on how much time and effort you want to spend drawing these very accurately. You are allowed to do problems that I assign, or to do even your quiz problems using this kind of graphical approach if that's what you want to do. Some people like doing that, other people do not. And so I leave that up to you. Now the next group of problems has to do with the analytical method of calculating the same kinds of findings. And the analytical method does not use a scale or drawing. It simply uses numbers and geometry and trigonometry to find your answers. Number 14 says, following path D in figure 358, calculate a total distance traveled. Okay, so the first is the distance. So the distance is going to be 2 blocks times 120 plus 6 blocks times 120 plus 4 blocks times 120. And you have to have the diagram in front of you to see where I'm getting these. And then the last is 1 block times 120. And so this is going to be 240 plus 720 plus 480 plus 120. And if you add that up, the distance is 1,560 meters. So the total distance traveled is 1,560 meters. Now, the second question is the magnitude and direction of displacement start to finish. And then I'll read the rest. In this part of the problem, explicitly show how you follow the steps of the analytic methods with vector addition. So in this case, you have to look at Sx, which is the x component of the displacement, and Sy, which is the y component of the displacement. The x component of the displacement is going to equal the following. 0 plus 720 plus 0 minus 120. Again, look at your diagram in the book. That'll help you figure out where I got these numbers. The y component of the displacement is going to be, this is 360. And then you know that S is going to equal the square root of 600 squared plus 240 squared, so that S is going to equal 646, or 0.22, which is 650 to the significant figures that they have. And the tangent of the angle theta is going to equal the side opposite, which is 240, divided by the side adjacent, which is 600. This also represents x and y here. And so the tangent, so the angle is the inverse tangent of this number. And when you calculate that, you get 21.8. Well, let's say 22 degrees. And in this case, it's going to be north of east. 22 degrees north of east. This is 0.4, and then when you do the tangent minus 1 of 0.4, you get 22. You actually get 21.801, which rounds up to 22 degrees. We'll do one more before we switch parts. Number 18 states the following. You drive 7.5 kilometers in a straight line in a direction 15 degrees east of north. Find the distances you would have to drive in straight east and north to arrive at the same point. So you start out, you're going north of east, 15 degrees east of north. Let me draw that properly. So 15 degrees east of north looks something like that. This being 15 degrees, and here's true north right here. And so the question is, what is, if you drove east and then north, so here's SX and SY, what would that be? Well, if you complete this, this is 75 degrees. And so this is the side opposite, and this is the side adjacent. Okay, this is 7.5 kilometers over here. So, in this case, the SX is going to equal whatever S is times the side. SX is the side adjacent to this angle, so that's adjacent over hypotenuse. So that's going to be the cosine of theta, and SY is going to equal S times the sine of theta. And so this is going to be equal to 7.5 cosine 75 degrees, and this is going to be 7.5 times the sine of 75 degrees. Now remember, the side opposite, just as a review, over hypotenuse is the sine of the angle, and the side adjacent to the angle over the hypotenuse is the cosine of the angle, of this angle 75. So if you do the math here, you get 1.94 meters here, and you get 7.27 meters here, 7.24 meters here. And so those are the two dimensions. This is the x component, and the y component. This is the due east component, and this is the due north component. If you look at your line, it makes a whole lot of sense. And you can see that if you do this, you can take this squared times this squared and take the square root of that, and you should get 7.5. And that's how you show that. Or you can also look at the diagram and see that you end up at the same place.